positive. So from I to J, it is a positive change in velocity. Another way of looking at why that would be positive. There is a PowerPoint where I go through an example. There are old tests that you can look at, some of which have actual answers. There are, and in the master set, there is one of these.
When's the test?
When is the test? I don't know yet. Probably not when I had it on the syllabus.
Does the textbook have examples too?
Not of the plus minus zero.
Okay, is it like a different way?
They go straight into, I feel like, the equations more quickly,
Oh, okay,
which is what we're about.
okay.
All right, so let's, other questions on this?
Do you think it would be beneficial to add numbers, like how we just did, about how fast it's going?
If that works for you, yes. I mean,
Okay.
I hate to make a sweeping statement for every person in here.
Mm.
All right, let's go with some numbers here. A ball rolled on a horizontal, you know what, slides on a horizontal frictionless surface. It is going at 30 meters per second, positive 30 meters per second for 4 seconds. So what is the ball's displacement? All right, start out with a simple one. Start out with it's sliding on a frictionless horizontal surface, similar to the problem we just did, that on the bottom level. And because some of you can look at that and already know the answer, I'm going to take it through some of the equations we've dealt with. I know that average velocity is equal to the change in position over change in time, or displacement over time. I can make anything into a fraction just by sticking it over 1. Now I have two fractions equal to each other. I cross multiply. I'm multiplying that and multiplying that. And so my average velocity over time is going to be equal to my displacement. That is an x. Now, since it's on a frictionless horizontal surface, the velocity is not changing. So what is the average velocity? It looked kind of like your mouth 0. Average velocity is not 0.
120?
Pardon?
120?
You answered a different question.
Okay.
What is the average velocity?
meters per second.
Yeah. It's going at 30 meters per second. It's on a horizontal frictionless surface. There's nothing that's going to change that. So it's 30 meters per second times 4 seconds. And you end up with the 120 that Monica mentioned. Units? Looks like you started to say it back there. What are the units?
120 meters per second. No.
Meters per second squared.
Displacement. All right, so let's look at the units. I take meters per second times seconds. And again, I can stick that over 1.
Meters.
Yeah, just meters. The seconds will cancel out and you're left with just meters. 120 meters. Now, on a test or quiz, you don't have to put the units in the middle, just make sure that the units are in the final answer. Okay, overall, a boring problem. Let's now change it. Questions on this before we have a changing velocity? All right, a box. Slides along a straight line. It is initially going 40 meters per second and accelerates uniformly at negative 10 meters per second squared for we'll say 6 seconds. After the 6 seconds, what is the box's velocity? Displacement? We'll stop there. I'm going to add to it, but we'll just start there. All right, so let's parse this. I need to put a plus sign right there to emphasize that is the initial velocity. It's going in the positive, starts out going in the positive direction, and it'll have negative acceleration. So I'm going to set up a little chart here to start with. I got time in seconds, and then I have velocity in meters per second. Starts out going positive 40 at time 0. 3, 4, 5, 6. Now that acceleration of negative 10 meters per second squared, acceleration negative 10 meters per second squared. That is the exact same thing as negative 10 meters per second per second. And acceleration is the change in velocity over the change in time. In other words, for every second that passes, the velocity changes by negative 10 meters per second. So after 1 second, my change is negative 10, so what is the velocity?
30.
After 2 seconds? After 3? At 4 seconds? At 5 seconds? I just heard negative 10, and that's 6.
Negative 20.
Now, this is not the most convenient way, for 6 seconds, yeah, that's not a problem. If I said after 40 seconds, doing the chart, it'd be a pain. All right, but we have at 6 seconds going negative 20 meters per second, so that's the answer to the first question. Negative 20 meters per second. So the displacement, just the vocabulary, when I say uniformly, that means constant. I know that my average velocity is equal to my displacement divided by time. So my displacement is going to be my average velocity times time. So I just need to figure out what my average velocity is. Well, how do you find an average?
Add them all up.
All right, so if we add them all up, divide by, not how many numbers there are. 7. Yeah, there's 6 seconds, but there are 7 numbers here. So if you add them up and divide by 7, what do you get? Not for an average.
10.
10, yeah. You get 10 meters per second. Because if you add them up, you would get 70, and then divide by 7, and you get 10. Now I did it by every second. We have 7 numbers there. But there's nothing really special about every second. Suppose I did it every 2 seconds. So let's just look at every 2 seconds. So I have 40, 20, 0, and negative 20. What's the average of those numbers? Yes, it's the same average. But there's nothing really special about every 2 seconds. Why not every 3 seconds? So if I did every 3 seconds, I'd get 40, 10, negative 20. What's the average of those 3 numbers?
It's 10.
It's the same average. But there's nothing really special about every 3 seconds. Why not every 6 seconds? If I did every 6 seconds, all I'm doing is averaging those 2 numbers, which would get you 10 again. So if acceleration is constant, my average velocity can also be found by just taking the first and the last velocities and averaging them. So we've done it 4 different ways, got the exact same answer. If we did not get the exact same answer all 4 ways, then something went wrong. So my displacement is going to be 10 meters per second times 6 seconds. It is a positive answer, which means that I'm going to end up 60 meters on the positive side of wherever I started. Not enough information to know what my position is, because I don't know where 0 is. But I do know that I end up 60 meters from where I started.
How would you write that on the test? 60 meters?
Yeah. If I end up on the negative side, then negative 60 meters. If you want to emphasize it's on the positive side, you go ahead on the plus side. So what's happening here is I got some starting point. I going off to, we'll just say to the right is positive. I go off in the positive direction. I know I turn around at 4 seconds. I come back and I end up, so this is where I end. So this is start, end. And my final displacement is where am I relative to where I started. That is my final my final position, or sorry, my final displacement. And that's 60 meters.
You want us to draw that in the test?
No, this is just a visual for the next part. But I want you to understand that it does turn around, it goes out, turns around, doesn't quite make it back to the starting point because I have a positive displacement. Questions to hear before I mess with some of your brains? All right. Now what I want to do is figure out what is the distance traveled. The distance traveled, I know I end up 60 meters from where I started, but I do travel all the way out here and then back. Think of a car odometer. It tells you the distance traveled, it doesn't tell you the displacement. Which from a physics point of view would be really interesting, but completely useless in terms of driving a car. Unless you're racing Usain Bolt. So what I need to do is figure out how far do I travel to here.
40 meters.
I know that's at 4 seconds. The average isn't 10. I start out going 40 meters per second here. I'm going 0 meters per second here. What is my average for the first 4 seconds? We're talking for the first 4 seconds, from the moment I start the problem to that moment I'm turning around, what is my average?
Is it 20?
It is indeed. So you could have averaged those 5 numbers, or just averaged the 0 to 40, but this is 20 meters per second. And that's for 4 seconds. So how far do I travel? What is my displacement for the first 4 seconds? I'm doing the same formula. My displacement for the first 4 seconds is 20 meters per second times 4 seconds. Doing the fancy math there. Pardon?
80 meters.
Yeah. So this is my starting point here. At this point, I'm 80 meters on the plus side. I end up 60 meters on the plus side, so how far have I traveled backwards?
20.
So I'll go 80 that way, I go 20 back. What is the distance traveled?
100 meters.
Yes. And so the distance traveled, no vector symbol, is 100 meters. My average speed, well, I went 100 meters in 6 seconds. So my average speed, and no vector symbol, is 100 meters divided by 6 seconds. 16.6 repeating meters per second. Something like that. Now recognize it's the first time we've done this problem. There will be a series of test questions. I'll set it up and I'll give you multiple parts. But pretty much be sure there's going to be some problem of this nature. Before we do another one like this, any questions? All right, let's make it harder. Sorry, let's make it look harder. Car, initially going, let's see, along a straight path. Car initially going negative 40 meters per second. Accelerates uniformly. At positive 9 meters per second squared for 10 seconds. I want to know final velocity, average velocity, displacement, time of when it stopped, it's going to turn around. The distance from start to whatever time that is, total distance traveled, and then average speed. Now, the order in which I present these is the order in which I would solve it. That does not necessarily mean it's the order in which you could solve it. There are multiple ways of approaching this. If you solve them out of the order in which I laid it out, because then by all means, just solve it in the order in which you do it, and then point an arrow and say, I solved this next, and then point an arrow, I use this in order to solve that. Or, let's suppose that you don't know how to figure this time out, the time at which it stopped. But if you knew it, you could solve for this. Just make up a number, use it for the rest of it. I'll mark off for that and give you credit for the rest of it if you used it right. If you get to a point when later on you go, oh, I know how to do it now, then just make a little note saying, I remembered how to do it later, here's how to actually solve for time. You don't have to redo all this stuff, just, but I still use this number for the rest of them. Just trying to see that you know how to do it. All right, so let's start out with finding the final velocity. I'm going to start the chart again. Time in seconds. After this one, I'll show you a different way of solving for it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I start out at negative 40. It's going to change by positive 9 each time, so after 1 second,
31. Or what do you,
say it again.
so by positive 9,
We change by positive 9,
so negative 31,
negative 31. Then
negative 22.
keep going.
Wouldn't that be 22?
It would be. Okay.
13, negative 13. Negative 4. 5. 14. 23. 32. 41. 50.
Okay. Now we can do a quick double check here. Just to make sure that we didn't make a mistake. I know my average velocity, well, in this case it's uniform, so my acceleration. Try that again. I can find my average acceleration, which is just my acceleration because it's constant, is the change in velocity over the change in time. I know it's supposed to be 9. My change, I go from negative 40 to 50, which is 90. Divided by 10 gives me 9, which is what I would expect. All right, so I know my final velocity.